Hi everyone. So today we'll be taking a look at arithmetic sequences. So an arithmetic sequence is where terms increase or decrease by a fixed number. So this fixed number is called the common difference. So let's take a look at a few examples. So in our first example, we have 1, 4, 7, 10, and 13. So if you look at this pattern closely, we see that each number is being incremented by 3, right? So in this example, the common difference is 3. Let's look at another example. 4, 2, 0, minus 2, minus 4. In this example, the next number is being decreased by 2. So in this case, our common difference is minus 2. Let's look at a third example. Here we have 3, 3, 3, and 3, right? So here what's happening is there is no increment nor there is any decrement, right? So in this example, our common difference is 0, right? So in the first example, we had a common difference of 3 because there is an increment of 3. Second example, our common difference was minus 2 because the numbers were decreasing. And a third example, because there was no change, the common difference was 0, right? So now, if I had to talk about the general term of an arithmetic sequence, you know, looking at the previous examples, we would have something, like a number. There we have a number a, and then it's being increased by some common difference, and then it's again being increased by a common difference. So it'd be a plus 2d, and then we have a plus 3d, and so on, right? This would be first term. This would be second term. This would be third term, fourth term, and so on. Right? So now the formula that's given in the IEP data booklet is quite straightforward, right? It says UN is equal to U1 plus D into N minus 1. Now let's talk about the different parts of this equation, right? UN, let's put this in yellow. UN states for the general term, right? So whenever a question ever asks us for a general term, they're asking for UN. They're asking for an expression in terms of UN. So they're asking something, UN is equal to U1 plus D into N minus 1, some format of that, right? Then we have U1. U1 is nothing but the first term, right? And oftentimes questions will even ask us to find the first term. And they might even give us an expression and say, find the first term. So what they're asking for is U1, right? And then we have our common difference. Now, oftentimes the questions will even ask us to find the common difference. Now, one simple way to find the common difference is to subtract two numbers in a sequence. Suppose I have term one. So suppose I have, let's say, I have UN, and then I have UN plus one, the term after that. So common difference is nothing but UN plus one minus UN, right? That is all we have to do. Let's look at an example. Suppose we have 2, 12, 22, and 32. So if we have to find the common difference in this term, all we have to do is just pick two numbers. Suppose this, or this, or this, right? Suppose I take 2 and 22. All I have to do is just subtract 12 from 22, and my common difference will be 10. If this is constant in every single difference, suppose if I do 32 minus 22, which is 10, 22 minus 12, which is 10, and 12 minus 2, which is 10, right? So I'm getting 10 in every time. That means my common difference is a constant value, and therefore this is an arithmetic sequence, right? This is how I can deduce whether something is an arithmetic sequence or not. Right? And finally we have our um, n, right? Our n is basically nothing but what term it is. It basically says first term. So whatever the subscript here is and here will always be the same. Right? That is basically what this entire the equation from the data booklet tells us. All right, now let's look at a few example questions. The fourth term of an arithmetic sequence is 18, and the common difference is minus 5. Determine the first term and the nth term. So, what we do in this question is we're given that the fourth term is 18 and the common difference is minus 5. Right? So let's write the information we have. U4 is 18 and common difference is minus 5. Right? So now to find the first term and the nth term, what we have to do is we have to write this entire expression in some sort of a general form. And we can do that by using our equation from the data booklet, which is nothing but un is equal to u1 plus d into n minus 1. Right? Now, what we do is we can simply just put in the values that we have, right? We have n is equal to 4 because it's the fourth term, right? So for n, we can put in 4. And for un, basically because it's u4, because it's the fourth term, so we'll just put in 18 here. So putting these values in, we get 18 is equal to u1 plus common difference is minus 5 into n is equal to 4 minus 1. So 18 is equal to u1 minus 5 into 3. And then we have 18 is equal to u1 minus 15. So u1, or our first term, is 33. Right? We have solved first half of this question. Right? Now we have to find the nth term. Right? Like I said, when they ask us to find the nth term, all we have to find is the un expression. So let's use our formula that we learned back here. Or before that, let me do this in a different color. So let's take green for this. So un is equal to u1 plus d into n minus 1. Right? So now we have our first term, which is 33, our common difference, which is minus 5, and n minus 1. So un is equal to 33 minus 5 n minus 1. Let's simplify this a little bit more. We get un minus 5n plus 5. And finally, we end up with un is equal to 38 minus 5n. And this is our nth term. So we have solved both of these questions. We found the first term and the nth term. And this is the answer to the question. All right, next question. Three numbers are consecutive numbers of an arithmetic sequence. The sum of the three numbers is 45, and their product is 3,240. Find the three numbers. All right, so before we get started, I would like to mention that this is a fairly common type of a problem, and there's actually a very standard approach to this as well. But before I share that with you, I want you to think about it very intuitively, and I'll even talk through it. So what this question is telling you that they're consecutive numbers of an arithmetic sequence. Now, I should also mention that these aren't consecutive numbers. They're consecutive numbers of an arithmetic sequence. So what I mean is that we don't have x plus 1, and x plus 2, right? We don't have three consecutive numbers like 1, 2, 3, or 7, 8, 9, or 55, 56, 57. So these numbers are not an they're not exactly consecutive. That is something I want you to remember, right? That shouldn't be the first thing that strikes in your brain, right? So what's actually happening is that we have some random number un, Okay, then we have un plus 1, the next term. It doesn't have to be the exact next term. It can be maybe 10 more, 10 more than the 10 more than un, or it can even be 7 less than un, right? It can be anything for that matter. We don't know, right? And un plus 2, right? Same process, same pattern with this as well. Now, let's thinking about it. We have some un number, the next number in the term, and the term after it. Their sum is equal to 45, and their product is equal to 3,240. So how do we think this through, right? We can let's work, let's work with variables at this point. We have x, y, and z, right? So let's, in this case, we can have three numbers. Suppose, let's say we have some number, a plus d, right? So logically, if it's an arithmetic sequence, this will be a plus 2d, and this number will be a plus 3d, right? This, what we have, makes a little bit more sense, right? Much more sense than what we had here, right? This is not exactly accurate. It may be possible, but it won't always work, right? 99% of the time, the consecutive numbers will never work, but this will work. However, if we take a closer look at it, we can solve this, right? But what happens is, if we find the sum and we find the product, we'll have some really, really hairy equations to, simplify. And that could take us hours and hours. And more than time, we'll most likely make a mistake in that. So what we do is, now this is the pattern, right? This is the approach which you must follow in every question, right? Even if, if I want you to learn something out of this question, it's to know the process, it's to know the standard process, because every student will have it memorized. Even if they don't understand it, they'll memorize this process and come and get the 6 points of the question, right? So regardless of whatever I've said so far, you just need to know this process and you can solve this question every single time, right? So previously we just talked about how we'd have three terms, right? So we'd have a plus d, a plus 2d, and a plus 3d, right? I could have even written this as a plus d, and a plus 2d. It wouldn't have made a difference. Now, on the next slide, what I'm going to write is a slightly more different term, right? Previously, I had what, x, y, and z as the terms in the arithmetic sequence. Now, instead of making this a, I'm going to make the y the a, okay? And I'm going to make z the a plus d, and I'm going to write x as a minus d, right? Now what we have done is we have made it much, much more simpler, right? Now what's gonna happen is, as we solve the question, there will be some cancellation, and we'll be left with really, really simple numbers working for when we'll work forward, right? So we're actually going to be using this pattern. We'll be using this pattern when we work forward. So now we have x as, or the first term of the sequence, the first term of the three consecutive terms as a minus d, a, and a plus d, right? If we subtract a minus d, we're left with our d, which is our common difference, right? So we haven't done anything wrong so far, right? So let's move forward from here. I'll change the color. And now, so our sum was, let me write it here. Sum was 45, and product was 3,240, right? So we have a minus d plus a plus a plus d is equal to 45. Straight off the bat, we see a minus d and a plus d, which immediately cancels out. So we're left with 3a is equal to 45, and a is equal to 15. There we go. We have found one of our numbers, right? The middle term, right, is equal to 15, right? Or our y is equal to 15. Now all we have to do is we have to find the common difference, and we can add that common difference and subtract the common difference and find our other two values of the sequence. Now, we have already found the value of a through the help of the sum. Now let's use the product, right? So we have a minus d. All right, let me write it. Maybe I'll write it like a line. and I'll write it right here. So a minus d, a, and a plus d is equal to 3,240. Sorry. Right? So now let's substitute 15 for a. So we get 15 minus d, 15, and 15 plus d is equal to 3,240. Let's take this. Let's take this right here. So we get 225 minus d squared is equal to 3,240 divided by 15, which is 216, right? Then we're left with 225 is minus 216 is equal to d squared. 9 is equal to d squared. And d, mind you that d will be plus and minus 3, both. Okay, it can be both of them, right? And both will be the answers. Now I'll tell you what happens after that, right? So now we have our common difference, right? So now if we take plus 3 as our common difference, what do we have? We have 15 obviously in the middle. Let's change the color. So we're left with 15 in the middle in both cases actually, right? But if we take plus 3 as the common difference, we get 18 here and 12 here. And if we take minus 3 as the common difference, we're left with 12 and 18, right? So these are our three consecutive terms. Now, if you take a closer look, right? 12, 15, 18, 18, 15, 12, they're the same thing, right? They're the same thing. So both of these answers, or both, doesn't really matter which one you take because they'll give the same answer, unless until the question had previously specified that the common difference is greater than zero or less than zero. Then we would have eliminated one of the options. But the question never specified that, so we take both cases into account. Either ways, they'll just be the mirror opposites of the each other, right? We have 12, 15, 18, and 18, 15, 12. Right? So this is how you solve questions where you have consecutive terms of an arithmetic sequence. Please do take a watch the video again, watch this part again, because this is a really important type of question and you should know how to solve these type of questions. All right, next question. The second term of an arithmetic sequence is 20, and the seventh term is 55. Find the first term and the common difference of the sequence, right? So this is some sort of it's a very fairly common and straightforward type of an IB question, right? So what have they given us? Let's compile all the information we have, right? Our second term u2 is equal to 20, and u7 is equal to 55, right? So let's use the formula from our data booklet, which says un is equal to u1 plus d into n minus 1, right? This is the equation from our data booklet. All I'm doing is I'll be using only this equation to solve the entire question, right? So now what I'm going to do is I'm going to plug in the values, whatever values I have, right? And what's going to happen is I'm going to have two simultaneous equations with u1 and d as my variables, right? And then I'm going to solve the simultaneous equation, find u1, and find the common difference. That'll be my answer. So let's get started. So I'm going to replace u2 right here. This will become 20 because it's the second term. It's a value of the second term, and it will be u1 because we don't know what u1 is. We don't know what the common difference is either. And I'm going to put 2 minus 1. So let's simplify this a bit more. So we're left with u1 plus d. So this is our first equation. Now we're going to make another similar equation like this, but using the seventh term. So we're going to have 55 is equal to u1 plus d into 7 minus 1. 55 is equal to u1 plus 6d. This is our second equation. Now, all we have to do is, this is middle school math right here. We just have to solve, do elimination, do substitution, whatever you need to. Find the values of d and u1. So let's do that as well. 20 is equal to u1 plus d. 55 is equal to u1 plus 6d. Let's subtract the equations. So we get minus 35 is equal to minus 5d. Common difference is plus 7. Right? Now all we have to do is just put the value of d in one of the equations, find the value of the first term. Right? Let's take the first equation because it's a lot more simpler than the second one. So 20 is equal to u1 plus 7. u1, or first term, is 13. So we have found both parts of the question, one which said first term, one which would require the first term. We have found that. And the other wanted us to find the common difference, which we have also found. And this is how you solve this question as well. Next question. If 9 times the ninth term of an arithmetic sequence is equal to 13 times 13th term, then the 22nd term of an arithmetic sequence is what? Now, in my opinion, this is a really, really nice question because you're not directly finding the first term or the common difference. But let me give you a little bit of a hint of how to solve. You actually have to set up the expression or the equation in such a way so that it tallies with the required answer, right? So I really suggest that you pause the video right now and really give it a shot. So what this question tells us that if 9 times the ninth term and 13 times the 13th term, right? So let's write this, let's write what it's actually saying so that, that you get a feel for what's happening, right? 9 times the ninth term, u9, is equal to 13 times 13. So how can we, move forward with this question, right? So what I'll do is I'll use the equation, our general equation, un is equal to u1 plus d into n minus 1. I'll use that in here and in here, right? So if we do that, what do we get? We get u9 is equal to u1 plus d into 9 minus 1 equal to 13 times u1 plus d into 13 minus 1. Right, let's simplify this. 9 is equal to u1 plus 8d, which is equal to 13 times u1 plus 12d. Right, if I simplify this more, what I'll get is 9u1 is equal to 72d. 13u1 is equal to 156d. Right, let's get all the terms on one end. So we'll get 0 is equal to 4u1 plus 84d. Right, this is what we're left with. Now, what the question is asking us, they want the 22nd term. They want the 20. Oh, my bad. They want the 22nd term, right? So, this is the tricky part. Oftentimes, if this is the first time you're seeing this question, you will be stumped, right? It's fine, no problem. So, how we can move forward with this question is that, again, let's use the general term that we have. un is equal to u1 plus d into n minus 1, right? So if you want this 22nd term, what would it be? u22 would be u1 plus d to 22 minus 1. So 22nd term will be u1 plus 21d, right? So if we can somehow get this part, if we can get this somehow in terms of this, basically we'll get u22, and therefore we can find the value of u22. Now, if we take a closer look at this equation and this equation, they're quite similar, right? Because if I divide both sides by 4, what I get is 0 is equal to u1 plus 21d. And now this and this are the same, right? So if they're the same, then this and this are the same, right? So double check mark, right? They're the same. Therefore, u22 is equal to 0. That is what we can conclude. Because what we did was we were able to set this and this equal to each other by simplifying this expression. Because of that, we got 0, and therefore our 22nd term is equal to 0. So in this question, we did not find the first term, and we did not find the common difference, and we still do not know what the first term and the common difference is, and that's absolutely okay, right? We didn't care about them, and we didn't find them, and yet we were able to satisfy what the question wanted us to do. All right, let's look at another question. This question's actually from 2010 of the IB past paper, right? So you can expect a questions of this level, right? At least of this level. And I'm sure, and I'm very much confident that there will be questions of much greater difficulty, but that's okay. Okay, so let's read the question. The nth term of an arithmetic sequence is given by un is equal to 5 plus 2n. Write down the common difference. Sorry. Write down the common difference. And given that the value of the nth term of the sequence is 115, find the value of n. And this second part of the part B, we'll ignore that because it's talking about sum of sequences. And once I teach you that, then we'll come back to this question and solve it. Okay, so let's get to the first part. It says write down the common difference of this arithmetic sequence. Now, honestly, just by observing it, you can tell that the common difference is 2. Right? Now, if it doesn't strike you, that's okay. Right? What we can do is we can take any two terms, any two consecutive terms of the sequence and subtract them with each other, and we can find the common difference. So let's look at the first term, for example. So un is equal to 5 plus 2n. Let n equal to 1, right? You want our first term. 5 is equal to 2 plus 1. Our first term is 7, right? Now, let's take our second term. So u2 is 5 plus 2 into 2. u2 is 5 plus 4. So u2 is 9. So now if we just do, so our common difference is nothing but u2 minus u1, right? It's any two consecutive terms. So 9 minus 7, which is 2, right? And we get the same value, right? This is how you solve problem. I mean, it's a very simple logical thing. I just did all this extra work just to convince you, right? Now let's look at part B. Okay. Given that the value of nth term of the sequence is 115, find the value of n, right? So they're saying un, some value of n gives us 115. And we have to find, right, n. We have to find what term it is. So what we can do is we can simply use our formula from the general formula from the data booklet, which says un is equal to u1 plus d into n minus 1, right? And for un, let's put 115 here because that's the value of some term, right? u1, we can use that by finding, or we found in the previous question, but suppose we never found the previous question, what would we do? We would use this part. We would use this. So what does it say? It says un is equal to 5 plus 2n. No problem. What we would do is we would put n is equal to 1, 5 plus 2 is equal to 7, right? So 7 was our first term, Common difference, we just found that in the first part A, and we don't know what n is because that's what we have to find. So that's it. Now we just solve for n. That's it. That is it. So all that's left of this question is nothing but just simple equation. So 7 plus 2n minus 2, 1, 1. 5 is equal to 5 plus 2n. 1, 1, 0 is equal to 2n. And n is equal to 55. Next question. Find the number of the terms in the sequence 4, 12, 20, and all the way up to 108. All right. So this again is a very, very formula-based question, right? Well, all we have to do is nothing but just use the general term u1 is equal to u1 plus d into n minus 1. Let's look at the first term. So first term is clearly 4 here, right? First term is 4. This is the second term. This is the third. And this is some nth term that we don't know, right? Now, to find the common difference, obviously, just take any two consecutive numbers. We could have taken u3 minus u2, or even u2 minus u. Doesn't make a difference at all. And if we take this, the difference between the two consecutive numbers, we get 8 in both cases. So our common difference is 8, right? So we have our first term, u1 is equal to 4, common difference is equal to 8, and we have our nth term, which is equal to 108, right? So if I have to color code this just so you guys, it's clear for you guys, I can do that as well. So we have un, all right? So this is just for your clarity. Now, let's plug in the values, right? So we have our nth term is 108 is equal to u1, which is 4, plus our common difference, which is 8 minus 1. Let's just simplify this equation. We get 4n plus 8n minus 8. 108 is equal to 8n minus 4. We can just simplify this equation a lot more. So if we just divide everything by 4, we get 20. We get 108 divided by 4. We get 27 is equal to 2n minus 1. Let's take this here. 28 is equal to 2n. So n is equal to 14. Right? So the number of terms in the sequence is 14. That's our answer. All right, next question. The number of terms common to the two arithmetic sequences 3, 7, 11 all the way up to 407 and 2, 9, 16 all the way up to 709 is what? So in my opinion, this is a really good question, and I suggest that you pause the video, give it some time, and then come back again. Okay, so our first sequence is 3, 7, 11, and 407. Our second sequence is 2, 9, 16, all the way up to 709, right? So again, this is a kind of a pattern question, you can say. There's a very standard approach you can follow, to be very honest, like one of the previous questions which we did, where we had the three consecutive numbers of an arithmetic sequence. So this is it's a pattern question where you should know the approach of after solving this question, you should be aware of the approach of or how to approach questions like these, right? So in this first sequence, what we can see is the common difference is 4, and in the second sequence, the common difference is 7, right? So the terms in the first sequence are being incremented by 4 every time. The terms in the second sequence are being incremented by 7 every time, right? Now, what we try to do in this question, is we try to find common terms, right? We're trying to find the common terms that lie in the sequence. Okay, so the most logical approach would just be to write as many numbers as possible, and then just tally them up with each sequences, and whatever the common ones are, those, and we count them up, and that's our answer. But obviously, when we have such huge numbers, when they're going all the way up to 407 or even 709, that would take a lot of time, right? So what we do in this question, we try to find the first common term, right? So if we try to find the first common term, we can just extend our sequences. So we get 3, 7, 11. We get 15. We get 15. We get 19. We get 23. We get 27. Right? Now let's extend the term. Let's extend the sequence for the second one. 2, 9, 16, 23, 30. Right? Now we can stop right here because we know we have got the first common term, right? In from both of them. So which is 23. Right? Now what we do something different here, right? What we do is we find a new arithmetic sequence, right? Which is common to both the first and the second. And what we do in this part is that we find the least common multiple of both of the common differences of the sequences, right? So in this example, what we do is we find the least common multiple of 4 and 7. And the least common multiple here is 28, right? So this becomes our new common difference, which we will use. And this becomes our in 23. So 23 becomes the new first term. And with this, we can generate a completely new, new sequence, one which has terms common to both 1 and 2. So let's do that. Let's do that on the next page. So we have 23 with a common difference as 28. So we'll have 51 and so on and so forth, right? We don't know how long it'll be. But what we do know is that they will finish before 407, anytime before 407. They can be 406, 405, they can even be 407. We do not know, right? So our first term is 23, and our common difference is 28, right? And our term is less than 407. It can be less than or equal to do that, for that matter. We do not know, so let's keep both cases. Let's not neglect 407, right? So what we do is we use our common term. Use our common formula. Sorry, u1 is equal to d into n minus 1, right? So what we do here is we write un is equal to 23 plus 28 into n minus 1, right? And we know that un is supposed to be less than or equal to 407. So what we do is we can write 23 plus 28 is equal to n minus 1 less than equal to 407, right? So now if we simplify this, right, we can subtract by 23 and then divide, right? So we get n minus 1 is less than 407 minus 23 upon 28. That gives us, this basically gives us nothing but n minus 1 is less than 96 by 7, right? Now if we add, so this is something, 13 point some value, right? Equal 13 point something something something, we don't know. So n minus 1 is less than or equal to 13 point something something, and so n is less than 14 point some value, and that goes on, right? So the number of terms that will be common will be 14, right? Because obviously you can have 14.2 term or 14.3 terms. So it'll be the least, so it'll be the greatest integer value, which is 14. right? So basically, to answer our question, it'll be the number of common terms will be the number of common terms are 14, and that's it. So like I mentioned, this is again one of those common type of questions that you will see, that you can see actually, and this is the standard approach to solving it as well. All right, so let's take a look at this question. The number of numbers lying between 100 and 500 that are divisible by 7, but not by 21 is what? Right? So we want to find all the numbers that are divisible by 7, but not by 21, right? So how do we start this, right? So again, this is kind of out of the box again, right? It's kind of similar to the previous one. Not exactly similar, but you almost get the same feeling that, it's looking at the same, it's going, leaning towards the same way. Okay. So what we do in this question is first we find, let's look at 21, right? So 21 is actually divisible by 7, right? 21 is divisible by 7, right? So technically, if we go to think about it, all the numbers, suppose all the numbers between 100 and 500 that are divisible by 21, they will be divisible by 7 as well, right? So if we have some, x numbers which are divisible by 21, some of them will, all of them will be divisible by 7 as well. So suppose you have 10 numbers which are divisible by 21, all those 10 numbers will also be divisible by 7. However, all numbers that are divisible by 7 will not be divisible by 21, right? So let's write that. So, all numbers divisible by 21 will be divisible by 7, but all numbers divisible by 7 will not be divisible by 20, right? This is important, right? We need to keep out for this, right? So what we can do, a possible approach could be to find all the numbers that are divisible by 27, because then all we have to do is we just have to eliminate all the numbers that are not that are divisible by 21, and we find the number of terms that the question asks us to find, right? So let's do that, right? So obviously we have to find the first term after 100. So obviously our first term will be greater than 100 and our last term will be less than 500. So if we, try to solve that, what we get is if we do 7 divided by 100, we get 1730, we get 428, 2. So our remainder comes out to be 2, right? So therefore, our first term, if we add basically 5 to this, right? So we get 7, which is a common multiple of which divides evenly with 7, obviously. So, basically 105 will be our first term, right? Because 98, because technically the number before this will be 98, which is divisible by 7. So what I did here was I got a remainder of 2 after dividing 100 with 7. So I just added 5, right? So I added 5 here, added 5 here. So I get 105, which will be the next, which will be the first number in this given sequence, which is divisible by 7, right? So, and let's find the last term as well, right? So 500, let's do it down here, actually. 500 divided by 7, 749, 101, 730, right? So 71 is our first, is our, 71. It goes in, sorry, let me repeat. 500 divided by 7, 71. Remainder gives us 3. So what we can do is we can do 71 times 3. Sorry, 71 times 7 gives us 7, 497. This is our greatest possible number that we can have, right? So now if we were to write a sequence, right? If we were to slightly modify our sequence, do we get? Our first term is 105, then it's 112, it's 119, 126, and it goes all the way up to 497, which is the largest possible value that satisfies the condition of being divisible by 7, right? Now, this number, if we take, now what we do is actually, we look at the first number, which is divisible by 21, right? So if we look closely, 105 is divisible by 21, right? 105 divided by 21 gives us 5, right? Now, this is being incremented by 7, this is being incremented by 7, and this is being incremented by 7. So when we increment it 3 times, we get 21. So, right? So this number and this number have a common difference of 21, right? So what we notice here is in every 3 terms, we get one number which is divisible by 21, right? So what we can deduce that for, suppose there are n numbers here in this sequence, right, from between 105 to 497, one third of the n numbers is divisible by 21, right? Therefore, two-thirds of n is only divisible by 7 and not by 21, right? And this is what we're looking for. This 2 by 3, 2n by 3, or two-thirds of n will give us our answer, right? So how do we do this? Nothing. We just use we just use our standard formula. Un is equal to u1 plus d into n minus 1. Our u1 from the previous slide is 105, and our common difference is 7. Why 7? Because we created a new term right here with where the common difference was 7, because we knew that all numbers uh, here, that whatever numbers are divisible by 21, we will eliminate them and we'll get the number of terms which are not divisible by 21. So u1 is equal to 105, common difference is equal to 7, right? And our right, to find the number of terms, you also have to find the nth term, right, which is the greatest term in the sequence, which is 497. So 497 is equal to u1, which is 105 plus 7 into n minus 1. So 497 is 105 plus 7n minus 7. And if we simplify this, we get n is equal to 57, right? N is equal to 57. So previously, in the previous slide, I had said two-thirds, one-third of n is divisible by 21, right? Because we saw that in a given of 3 sets, three consecutive numbers of the sequence, one of them was always divisible by 21. Why? Because 3 times of the common difference gives us 21, which gives us a new common difference of 21, right? So all we have to do is to find the number of terms which are divisible by 7 and not by 21. All we do is two-thirds of sorry, not 21. We do 57. 57 is equal to our answer, right? So 19. So 38 is our answer, right? So basically, there are 38 terms, right? There are 38 terms which are divisible by 7 and not by 21, right? This is our answer. right? All right, so this was all for today's video. Next video, in the next lecture, we'll look at arithmetic series, basically the sum of of arithmetic terms, right? And after that, we'll look at geometric sequences and then geometric series. So that's all for today, and see you in the next video. Bye bye.